Okay, so welcome to our second common session of Sunoikis Digital Classics 2016. Last week we had the introduction to the course, but today we have our first real common session with the first part of introduction to Treebanking with Giuseppe Celano from the University of Leipzig and Doug Haug from the University of Oslo. As you know, you have the class outline in GitHub and the slides. But now we can start with Giuseppe. Please, Giuseppe.
Yeah.
Okay, we see your screen. Excellent.
Okay. Can you hear me?
Yes.
Yeah.
Yes.
So thank you, Monica. So today we are gonna introduce Treebanking. This is the first part, and the session is kind of special in the sense that it is bipartite, I would say, because I'm going to introduce some basic notions on Treebanking, and then Doug is going to say more about the Royal Treebank and how we can query Treebanks, because this is extremely important in the sense that Treebanking is useful not only for pure linguistic research. But let's start with my parts. I will provide you with some very basic information about Treebanking. Then I will focus on the ancient Greek and Latin dependency Treebank, which is the Treebank we are developing in Leipzig and at Tufts University. And then I will try to Treebank something with you to show how to Treebank, because I would like you basically to see what you are expected to do if you wanted to Treebank. First of all, a very informal definition. Treebanking is the activity of building linguistic trees. I use the term, this rather generic term linguistic, because there are different kinds of linguistic trees contained in a tree bank. Of course, we have syntactic trees, but we should also remember that the syntactic annotation relies on usually on a morphological annotation. So this is the first layer of annotation that we find in a tree bank. And sometimes, if we are lucky, we can also find a semantic layer. Of course, annotating the semantics of a text is particularly complex and challenging. But as you can understand, the more information we put in our corpus, the better it is, because we can simply perform more powerful queries if we also have some semantic annotation. A tree bank is, of course, simply a corpus containing linguistic trees, syntactic trees, or even semantic trees. So now I think you should be able to see a nice tree for a simple Latin sentence. This is a very nice, I would say, graphical representation where you can read the Latin sentence and then see how the annotator has built the syntactic tree for this sentence. Let me read the sentence and translate it, because the challenge here with Treebanking, at least in my opinion, is that if you can understand the meaning of the sentence, you should be able also to build the syntactic tree. Of course, there are some technicalities, so for some kind of nodes you need some study, but in general, I think that the work of the Treebanker is pretty intuitive. For example, here we have primus ex hac magistratum populi suffragio cepit Gaius Rufus. So the translation, a translation could sound Gaius Rufus took, so if the translation is literal, took first of this tribe, took a magistracy by vote of the people. So a better translation would be Gaius Rufus was the first who took a magistracy by vote of the people. Okay. If we focus on the tree, you can see here that the root, the linguistic root of the tree is the verb cepit, whose label is pred, meaning predicate. Okay, so we acknowledge basically that the verb, the main verb of a sentence, has a kind of a special role within the sentence, because it is on the basis of this verb that we can know, or we can expect other cases. For example, if we see cepit, we expect that our sentence contains a subject, of course, the one who cepit, and at the same time we expect also to know what was taken, basically, so the object. And this is basically the reason why we attach Rufus to cepit, and we attach magistratum to cepit, and the labels are, I would say, pretty clear. Rufus is simply the subject, and magistratum is the object. Similarly, suffragio is another dependent, what we call dependent, that is in this case a word, a constituent, which is also attached to cepit, because it simply specifies something about this action of taking. More precisely, the author says that Rufus took the magistrates by vote, okay, of the people. And again, similarly, populi is attached to suffragio simply because it specifies something about the vote. The vote was that of the people. I'm not saying anything about primus ex hac, because this is a kind of more complex node. So I think that for beginners, it's better to leave this out for now. Here you have a formal definition for linguistic tree. I think that this is important to show this, even if we try to keep things simple, because it's important to remember that tree banking can be formally defined, it can be mathematically defined. For example, a definition is for a dependency graph is that it is a labeled directed graph, and you can, if you are interested in knowing more about this, you can read the dependency parsing by Nivre. Here you have an XML serialization of the tree that I showed you. This is simply how the data are encoded. This is the underlying representation of our data. And again, this is important to be aware of how the file works, because if you wanted to query a tree bank, you of course need to exactly know how the pieces of information have been encoded. Here again, the I think that this XML fragment is pretty clear. This is the serialization that we use for the ancient Greek and Latin dependency tree bank. The Royal Tree Bank has a very similar serialization. Here, as you can see, we have a sentence element, and it is specified for some attributes which simply say something about the sentence. This is the sentence number 5, for example, and we know here we have a URN which specifies the work to which this sentence belongs to. Similarly, then you have a lot of words, and each word again is specified by a number of attributes. The form is, of course, the word form, basically the word that we find in the text. Then we have the lemma, the part of speech tag, which is the morphological annotation. Then we have the relation attribute containing the label for the syntactic, the syntactic label which says what kind of relationship the dependent has with respect to its governor, in this case Rufus. The head here means that this word primus is governed or is dependent on the word with ID number 9, which is Rufus. So as you can see, it is, I think, pretty easy to understand how this works. Another kind of serialization is just a plain text serialization. This is pretty common among for tree banks. I think that again it is pretty easy to understand it. We have the same values, but the same values, and just the position of each values defines basically what kind of value we are talking about. So the first column is for the ID of the word, simply. The second is for the word form, the third for the lemma, and so on. Okay, another I'd say.
Sorry.
Yeah.
Can I interrupt you 1 second? There is a question from students. We have 16 viewers, and I can see the question. So can you very briefly just say a few words about the difference between the 2 previous slides, and just very, very briefly say what is XML, because there are students who don't know that. Giuseppe, you should unmute yourself because I can't.
Can you hear me? Can you hear me? Yes. Great. Sorry. I was saying that, so basically what I'm showing here is what you find in your file when you download it after tree banking a number of sentences. So this kind of visualization is extremely nice, and it's extremely helpful, but what I'm saying is that the real data, the data that you have to deal with, is the data represented by this fragment. So XML, in a few words, is simply a format that allows you to describe a text distinguishing between the markup Okay, so something that we say about a text, in this case, and the value, the text itself. For example, here we have, if you read here, form means basically is a way to say, okay, I'm talking about the word form of my text, and the value for this word form is primus. Okay. Again, here everything is a little bit more simple in terms of encoding, because we just have a text and we don't have an explicit markup. I mean, the markup has to be inferred, and as I was saying, by the position of the columns. So I don't know if so the question is a very complex, and I think that I don't really have time, because this would take hours to explain how this works. So I would simply go on. So I was saying that there are two different kinds of tree banks, constituency tree banks and dependency tree banks. I have so far just shown examples from a dependency tree bank. Again, here the concepts are complex. I just want you to know that there exist different kinds of tree banks. I'm not expecting that you can understand everything right now, but the point is, if we take the same sentence, for example, the house at the end of the street is red, as you can see, we can basically we can annotate it in a different way. If we choose a constituency structure, we explicitly acknowledge the existence of, for example, a prepositional phrase here, of the streets. Okay, here we are saying that of the street is a prepositional phrase, whose head is the preposition, and then we have the street, which is a noun phrase, which is it depends on the which is part of the prepositional phrase. On the other hand, if we look at the dependency structure, we have apparently a simpler structure, because we don't acknowledge, again, explicitly the existence of a prepositional phrase, but still you can see that we annotate the existence of a preposition, and then we say that a noun depends on this preposition, and so on. Again, I just wanted you to know that there exist different kinds of tree banks, and so if you are looking on the web for a tree bank, you should always be aware that there is this distinction. So another piece of information here is universal dependency. This is a very interesting project. I'm mentioning here now because I think that it is really promising, and since it comprises, since the aim of this project is to annotate all languages, or at least a lot of languages using the same annotation scheme, I think that this is really pretty cool. And so if you are, for example, looking for some data for a specific language, both modern and ancient languages, you can go on the website of the Universal Dependency and see if you can find something, because you are very likely to find your language and to find data on which you can work. But now, getting to the tree banks for ancient Greek and Latin, we currently have three main tree banks: the ancient Greek and Latin dependency tree bank, the Proyal tree bank, and the Index Thomisticus tree bank. I'm going to focus on the ancient Greek and Latin dependency tree bank because, as I said, it is the one we are developing in Leipzig, and it is also the one which contains more text as for ancient Greek and Latin, because as Doug will show, the Project Treebank is really a great resource because it also contains other ancient languages, not only ancient Greek and Latin. But for, I mean, if you are interested only in ancient Greek and Latin, you should also have a look at the ancient Greek and Latin dependency tree bank and at the Project Treebank. And if you are interested in also in the Latin of Thomas Aquinas, you of course you need to look at the Index Thomisticus tree banks. This is a very this is just one slide to have a vague idea of what the ancient Greek and Latin dependency tree bank contains. As you can see, we have more text for ancient Greek, but in general, I think that also for Latin we have a respectful amount of tokens. By token, I mean both words and punctuation marks. When you if you want a tree bank, what you should have on your desk, or at least a document that you should have on your desktop on your computer or on your desk, is the guidelines. That is the document where you can find instructions about how to annotate a certain phenomenon. This is extremely important because even if tree banking is partly intuitive, because for some phenomena, basically, you can, I think that you can clearly understand how to build a tree without actually reading the guidelines. Still, there are a lot of technicalities, and sometimes we simply need to take a position, to make a choice, and this is why we write guidelines. And then, of course, you also need a tool for annotating. For example, in Leipzig, we have Arethusa, and this is the tool that we are going to use to annotate our sentences also now. For example, here is an example. Here is a simple fable by Phaedrus. If we wanted to tree bank it, please just a second that I need to share my screen. Okay. Can you see my Can you see my screen with the sentence in Arethusa?
Yes, yes.
Okay, great. So, so this is Arethusa, our tool to annotate sentences, Latin and Greek, but not only Latin and Greek. And now, what I wanted to do is simply to show you how I tree bank, so that maybe you can also do this by yourself, especially with the exercises that I put in the wiki. So first of all, you have to read the sentence and you have to understand it, of course, otherwise you cannot tree bank anything. Amitit merito proprium qui alienum adpetit. So a translation may sound the one who strives for another's possession loses his own possession deservedly. Okay? So once you have understood the meaning of the sentence, we usually start by annotating the morphology of each word. For example, Emitted is a verb. In this case, if you click on the morphological tab, you can see the possible options. In this case, we are lucky because we just have one possible option. This is clearly a verb, so we can click here and then save. And as you can see, so here it is failed because I'm not logged in, but this is not a problem right now. If you are logged in, basically your work is saved. What is interesting to see here is that the word gets read because I have associated to it the part of speech of verb. So I have annotated that this is a verb, and this is why it turns out to be read. I can, of course, go on with my annotation here. I don't know. I can say that qui is a pronoun, and probably this is singular and masculine and a nominative. So this is why I can click here. And again, as you can see here, we have a violet because the word is a pronoun. I have annotated it as a pronoun, and I can so basically go on with my morphological annotation for each word. After I have done this, of course I cannot do this right now. You should try to build the syntactic tree, which means try to put the words together, to connect words together. For example, here the main verb of this sentence is emitted, right? So, and this is why I usually start with emitted. Then I can also go on the tab relation and select pred, for example. So I'm basically claiming, by doing this, I'm claiming that this is that this word I associate the label predicate to this word, and then I can go on trying to connect the other words. For example, I would say that emitted requires a subject, and this subject is represented here by this clause, qui alienum adpetit, right? This is so. How can I annotate that I see this has the subject of this verb? Of course, a rule when I work within within a dependency framework, but not a constituency one, is that I can simply take one word and attach it to just another word. So I cannot, to put it more simply, I cannot take more than one word and attach them at the same time to another word. So I need to find a logic to annotate what I understand, but a way that, of course, makes some sense. So what we do here is simply to take the verb here, adpetit, we attach it to emitted, to the predicate, and then we take alienum and we attach it to the verb of the relative clause, and then we take the pronoun and we attach it to adpetit. So let me add the labels, because I think that this may help you to understand what's going on here. And also, okay, so this is the tree, the final tree for this sentence, and I think that the labels, probably the labels for merito and proprium and the attachment is pretty clear. Maybe it is not that clear why I have annotated the relative clause this way. So the point is here I acknowledge that the main the main constituents of a clause is its verb, and in this case its adjective. So this is why if I have to choose basically a word of the clause to attach to adjective, I choose the verb of the clause as a kind of, it's like it is representing in this case the entire clause, and I associate to this verb the function that the entire clause has with respect to the verb. In this case, this is right the subject of adjective. So the one who strives for another's possession. So this is the subject again. Loses. So subject and predicate. If we then focus on the on this sentence, what we can see is that qui, of course, qui is the subject, but the subject of the verb appetit, and alienum is the object of this verb. So, and this is why they get the labels subject and object respectively. So I don't know if this is clear, but basically what we do for each sentence is exactly this thing. So I know that I don't have much. How much time do we have, Monica? Because
in total we have 45 minutes.
Okay, so since I know that, I just wanted to show this sentence, something of this sentence, because this would take too much time. But again, so this is a very long sentence. This is more complex. What we should do is first, again, to understand, to translate it, which basically means to understand the meaning of the sentence, and then find the main verb. Here, the translation is a dog while bringing a piece of meat through a river saw swimming his image in the mirror of the water, and thinking that another aliam, another predam, was brought by another one, probably another dog, wanted to take it, wanted to take the prey. Okay, so here we have basically the problem with this sentence is that we have a coordination here. So the problem is how we can Treebank a coordination. And our solution is to take the coordinator, in this case qui, and then attach the two verbs, coordinate verbs to each. In this case, vidit and voluit, right? And then, so these are simply predco, right? So which means a predicate coordinated. Again here, and this is simply the coordinator, okay? So then I can simply go on as I did for the previous sentence. For example, here in vidit, I think that you acknowledge that this is the object simulacrum, and sus is an attribute of simulacrum, and again, in speculum could be wait a second. Okay, so I can then take in and attach. So I can create this structure. So as you can see, see here, I'm basically claiming that I'm trying to reconstruct in a sense the translation. So his image, simulacrum, in the mirror, speculo, lympharum, of the water. Okay, again, Nathans is here. So what about Nathans? probably I would put it here as an adjunct, as a modification of, again, the verb vidit, because he saw while swimming, right? So this is why we attach Nathan's to vidit. And if we focus on the other coordinated clause, again, here we can say that so the infinitive probably goes with voluit, and then again we have putans that I would attach to voluit, okay, because he wanted, because he thought something, and what he thought is that another prey was brought, so aliam predam was brought by another one. So this is another clause, right? And the way we treebank it is this way. So basically so this is thinking, putans, thinking that another prey, this is the subject, right? And ferry is the verb of this clause, depending on putans, and what is the function of this clause? I think that, again, you should be able to acknowledge that the function is that of an object with respect to putans. So putans what? Putans that another prey was brought by another one. So this is why we put the label obj on ferry. And then we can basically go on this way and build the entire tree. I think that maybe now it's time for Doug to start his talk. Otherwise, I'm taking all the time.
Okay.
Is it okay?
Yes. Doug, share your.
Yeah. Thank you very much. Okay, and thank you to Giuseppe for giving us a nice introduction to tree banks and what they are. So I'm going to share my screen. So, can you see my slides?
Yes.
Sorry. Okay. So I'll talk about how to query the data in tree banks. That is, how to retrieve the data you just put in the way Giuseppe showed you. And this is how we use the tree banks. But first, I'll say a little bit more about the Proyal tree bank, which is what I'm going to use as an example here, although many of the query techniques will be the same across tree banks. So the Proyal tree bank is a tree bank covering ancient Indo-European languages. We started out by tree banking the New Testament translations, so obviously the original in the case of Greek, but then the Vulgate in Latin, the Codex Marianus translation into Old Church Slavonic, the Gothic, and the Classical Armenian translations. So here are a number of words we have in the various languages. So the Classical Armenian, Gothic, and Old Church Slavonic corpora are basically limited to New Testament texts of varying size, but we have 60 to 70,000 words of Gothic and Old Church Slavonic. But the Greek and Latin corpora you see are much bigger because we have added more text beside the original Bible text. But the core is this parallel corpus of ancient Indo-European languages, and we are looking at currently at adding more ancient languages, including Old Lithuanian, Hittite, and Vedic, although that obviously will not be Bible texts. So let us look at the Greek and Latin text that we have beyond the Bible. So for Greek, we have Don Herodotus, about half the text. We have the first book, we have the last part of book 4, and we have books 5 to 7 as a sample. Then we have done some very late medieval Greek, the Chronicon Minos by Francis. This is a 15th century eyewitness description of the fall of Constantinople. A very interesting text, obviously very different when it comes to the language. Then in Latin, we have done books 1 to 4 and book 6 of the Gallic War by Caesar. And we have done some books of the letters of Cicero's letters to Atticus, and we have most of books 1, 3, and 4, and sporadic coverage of other books, and a bit of Cicero's De Officiis. And then also some late Latin text. We have done the Peregrinatio Aeterea, which is complete. So this is what we have now, and we're constantly adding to this. So the way we annotate is, when it comes to morphology, it's very similar to the ancient Greek dependency tree bank. You can look up there may be minor differences of detail, but basically the tag set is very similar, and it's in a way given by the structure of the Latin and Greek languages. So we annotate the features that are expressed morphologically. In the syntax, we're similar. We're also doing dependency annotation, but we're different in details from the ancient Greek dependency tree bank. I don't want to spend time on the details anyway, because the focus here is on how to query. But obviously, if you want to do serious work with these corpora and use them in your own studies or for a term paper or something, you do need to dig deeply into the annotation guidelines. We have something that no other ancient corpus has, namely information structure annotation. That is, we have annotated all noun phrases for whether they represent a new referent or some discourse old referent that has been previously mentioned, or a generally known entity, and things like that. This kind of annotation is only available in the New Testament and in Caesar, but it's very useful, for example, for research on word order. We also have semantics. We have animacy, so noun phrases are annotated for animacy. So these are the kinds of annotations you get in our corpus, but we're focusing on syntax today. So first I'll say a little bit about the availability of the data. There are 3 different ways you can get at our data. So here first is a link to the web page that we're using for annotation, but which is also open for browsing. So if you go to this link, you can look at our corpus, and you can do some very simple queries involving only a single token at a time. So for example, you can find all subjects that are nouns and represent new information in the sentence. It's possible to do that query. But typically when we do syntactic research, we want to look at relationships between several words, as in the tree structures that Giuseppe has been showing you. So, and that you can't do on this web page. Then there is the INES web page, which I'm going to talk about, which allows deep querying of morphology and syntax. And then finally, at GitHub, you can download our source data. These will be XML files or CONL files, very similar to the ones that Giuseppe showed you. And this will give you access to all annotations and full flexibility in what you want to do with the data. But obviously, it also requires a lot of computational skills. So for today, the focus is on this sort of intermediate level, the INES webpage, where you can get a lot of information out of a corpora without having to learn too much computer stuff. The query language used in INES is based on Tiger Search, which is also the basis for many other search engines. There is a search engine called Tiger Search. There are others using similar query languages. So in a sense, if you spend some effort to learn this query language, it does transfer, not in every detail, but it does transfer largely to other tools that are available. Okay, INES is a portal offering access to many different tree banks. This is a Norwegian project run by the University of Bergen, and they offer queries to very many languages and very many tree banks in different formats. Not only dependency tree banks, but also constituency tree banks, LFG tree banks, HBSG tree banks. But we're only going to look at the Proyal corpus, which is annotated as a dependency structure, like the ones Giuseppe showed you. This portal works best in Chrome, so that's just a detail you need to know. And to be able to use it, you need to know really two things. You need to know the query language based on Tiger Search, as I said. This is the sort of invariant that you need to know for any corpus in the NES portal if you want to use it. But then you also need to know the particulars of the corpus you're looking at. So that's in our case ProL, although we won't spend time on details that are ProL specific. So first we need to choose the right corpus, and now I'm going to show you the web page, and then we'll see what it looks like. So to do that, I guess I need to go here, share my screen. Oh wait, I need to share the. So do you see my?
No, I think you have to.
No, yeah, here. Wait. So here.
Yes, it works.
Yeah. So this is the web page. Treebank selection is where you go. We're going to look. So if you click ProL, you're going to get a list of all the ProL corpora in the Treebank. There are lots of Latin corpora, but in practice, many of them are empty because we haven't done much annotation, all these Plautus corpora. But you see the Marianus I was talking about, the Bible text in Church Slavonic, Gothic, and so on. So for our purposes today, I'm just going to choose the Gallic War. So that's what we'll be looking at. So when you choose the corpus like this, you simply get the beginning of the text, right? Gallia est omnis divisa in partes res, and so on. Very well-known text. You can click on it, and you get tree structures that are similar in the basics to the trees Giuseppe showed you. So that's the first thing you need to know to be able to query. Then, so when I do this, do you see my slides again, or you still see my web page?
I still see the web page.
Okay, that's fine. Okay, not a problem. That's okay for me. So the web page has this documentation page where you get documentation of the query language. There's a lot of things here because there's a lot of flexibility in what you can do. But we'll cover the main things today, and you don't need to care about those details. So the thing to remember here is that the data are represented as tree structures, just like Giuseppe showed you, which means that we have two basic things to care about, or three basic things maybe. So we have edges or lines in the tree, which represent the structure of the sentence. Then we have labels on those edges, which represent syntactic functions like pred, oblique, attribute, and so on, apposition, subject, object. And then finally, we have the words, or the nodes of the graph. Those are the words, and those nodes have attributes. So I can click on this, and you'll see that est here has the lemma sum, the part of speech tag v, which stands for verb, and the morphological tag, which we'll learn to decode. This is third singular, present, indicative, active, inflecting, but we'll learn more about that. So we do have something which is not present in the Greek dependency Treebank, which is several. So it's a node here can be linked to two different nodes. So Gallia here is the subject of est, but is also the external subject of divisa. I'm not going to say more about this. It's a slightly more complex structure. If you need to know about it, you can look it up in the guidelines if you do serious research, but it's not needed for just getting basics out of the data. So when we query, we want to constrain the structures that we get back, right? So we have, now that we look at the sentence overview, we get every sentence in the corpus, but we want to have only some. That's the whole idea. And we do that by querying for the features of the words. At least we'll start out with that, and then we'll do syntax later. So the feature that contains the form of the word is called simply word. So if we do this, we'll find every example of est in the tree in the current tree bank. So we can see here that we're querying only the corpus called Lat Kais Galdep, which means Latin Caesar Gallic War dependency. So now we get all the sentences that contain the word est. Maybe not the most interesting query, but at least it's a starting point. We can click on it and we get the tree with the matching node highlighted. So in this, and we get submatches here, so it can of course happen that in a single tree you have several occurrences of est. If so, you can go through them here. You get several submatches. Okay, so if we look at the structure of this thing, inside the square brackets, we get a description of a node, and that description is formed by a pair of a feature, an attribute, in this case word, and then on the other side of the equal sign, we get a description of that attribute, and that description is a regular expression. So we won't go a lot into the details of regular expressions, but we do need to say something. So, for example, we have dots, which will match everything. So now I find not only est, but any word consisting of e, s, and one more letter. Of course, this will actually probably only match est in this case, but so the dot acts as a wildcard. We can also put things inside square brackets to get a character class which will match any of the characters inside. So, for example, I'm going to give you an example right away. Here, if we do this, this will match any word consisting of A, M, A, and then S or T. Right, so this matches amas and amat. And we look for it, and then unfortunately, Caesar doesn't talk much about love. So we get no hits, but that's okay. And finally, we can use a limited form of quantifiers over the regular expressions that we have. So, for example, we can use a question mark to say optionality, that is 0 or 1. Right? If I do this, this will you'll find ama and amat. So the question mark means that the t is optional, 0 or 1 t's. If I do a star, it means any amount of t's, 0 or more. So amat, amat, and so on. Obviously, you're not going to find anything with that, but we'll see this in more practical use later. And then the final thing you can do is to have a plus, which will match 1 or more characters. So amat will match amat and any amount of t's, whereas the star will match ama and amat and any amount of t's. So the star means 0 or more, and the plus means 1 or more. Okay. So that's for the words, but obviously the most of the use of regular expressions here lie in matching morphological tags and not really the words. So the first thing is the part of speech tag, and we can look at. Let me have a look here. So this is a list of the part of speech tags in our corpus. Here you see it consists of 2 letters. The first one gives the major part of speech, adjective, or conjunction, or adverb, and then the second one gives a subtype if there is any. So df is a normal adverb, dq is a relative adverb, du is an interrogative adverb, and for nouns, for example, nb is a common noun and ne is a proper noun. So now we can use these tags. So we'll find all, oops, sorry. This will then find all proper names. So you see Garonna, the Garon, and so on. This gives us all the proper names in Caesar, in the tree bank of Caesar. And we can find the common names. Obviously many more. And we can find both of them, right? So this matches an N followed by an E or a B. So now we find both proper names and common names. Now this one, since we know there are only two possibilities, nouns are either common nouns or proper nouns, we could also do this, right? So this matches N followed by any character. In practice, we know only B and E are listed because they're the only one listed here. But we can do that and we get the same hit. So we have all the nouns. Obviously here we do get submatches, so now we have a big tree, and we can see the second noun or the 13th noun in the tree, or we can have all of them light up. So now we get all the nouns. So that's the part of speech tag, which is often very useful in constructing queries. And the morph tag works in the same way, but there are actually 10 fields. So those 10 fields, so you can have 10 letters, or you always have 10 letters, representing person, number, tense, mood, voice, gender, case, degree, strength, and inflection. So all this is mentioned on my slides, but I'll stay with the web page in order not to jump too much back and forth. But if you look up the slides afterwards, you'll see what codes there are. We do so. Person, for example, to take an easy case, can have the value of 1, 2, or 3, and it's the first field, which means that we can find any first-person verb in this way. So what I'm saying here is that the morph tag should start with 1 and then be followed by any amounts of anything, right? Dot means anything, star means any amount, so any amount of anything. Any tag that starts with 1. We run the query, and there aren't that many first-person verbs, but there are some. So let us see, we're going to have them. Oh, right, yeah. So I didn't say it should be a verb, right? So in this case, we get a first-person pronoun. So that's fine. The number is, the second tag is number, so we could say only first-person singular. Any amount of anything. If I do this, it's 1 followed by any amount of s's. But I want 1 and then s and then anything. So any first-person singular. So now, yeah, then I need to go to the queries again, and then we have nostra, right? Because nostra, again, it's singular ablative. Obviously, pronouns like nostra are tricky because they have two kinds of person features. But that's okay. Here we have a verb, first-person singular. So that's how you can query the morphological tag. We'll do more complicated examples. So let me just put in this third SRIA 1, 2, 3, 4 I. So the final tag says inflecting, and anything that inflects has this I at the end. So let's see. We have 282 examples. These will be third-person, singular, perfect, indicative, active, inflecting verbs. Look up the first example just to check that we got it right. Fuit. So this is a perfect tense verb in the third-person singular, indicative, active. We can find all non-inflecting words in the corpus. Let's see. So there are 10 fields. I need to put 9. This gives us all non-inflecting words in the corpus. So prepositions, other kinds of words. We can find, let's have a look, so we can have a word that is plural Key fields we don't care about. Masculine, ablative, affecting. So now we find those, like aquitanis and so on, ablatives, plural ablatives, masculine. So this is very useful to find forms that you're looking at. But typically, we're not interested in querying all the fields at the same time, the way we do here, right? I specify the whole tag, but we may be interested in only a single feature, and that's when the dot is your friend. So let's say we only want to look at the perfect tense verbs because we're doing some sort of study of perfect tense verbs. We'll find them all with 2 dots and then R, because R is so tense is the third field, and the code is R for perfect. And now we have 954 verbs. Yeah. And we can go through them here. We'll show later how to tabulate the data. So you get also participles, maybe you're only interested in the indicatives. So in that case, we need to specify mood as well, but we'll skip that now. Or you could be interested only in superlatives, because you're doing a study of that. That's, let me see, so 1, 2, 3, 4, 5, 6, 7, and then an S. That's superlatives. So 139 matches. Longissime. Right. We can also combine several constraints. So this one I'm going to cut and paste from my slides. So for example, let's say we wanted to know something about the ablative ending in the third declension adjectives. You know, this can end in I or E, so E or E, and we want to find those. Then we could do a more complex query, which will look like this, right? So the morphology should be ablative. The part of speech should be adjective, and the word should end in E or E. So now we find things like ulteriore, and then we also find things like somewhere incredibili, right? So we have the ones that end in E and the ones that end in E, and we can look at the syntactic context they occur in, for example. This will be one possibility. Now, something very useful when we do more complex queries is to name the nodes, because then we can express relationships between them. So a node name always consists of this hashtag and then followed by some letters, and it's prefixed to the node description with this colon, right? So now I get the same results, but I have a name for that node. It's called X, and I can use that name in constructing more complex queries. Another nice effect of this is that if you now click on query instead of sentence, you can get a table. So for example, here you see the occurrences. So we have 11 occurrences of superiore, 6 occurrences of comuni, and so on. You get a frequency list of all the words matching those. So that can be useful in many cases when you do research based on the data. Here. And but apart from that, when you do morphological queries, node names are not that necessary. But when you look at syntax, you really need to use variable names, because you want to express relations between nodes, and you get very complex queries. So, in order to study syntax in the corpus, we need 2 relations. So if you think of the trees that Giuseppe showed you, they're 2-dimensional. So there's a sort of up and down, which corresponds to syntactic governance or dominance, which is represented with this, so the greater than sign in the query language. And then there's the horizontal dimension, so precedence in the sentence, which is represented with this dot. Again, so careful. The dot means 2 different things. When it's inside quotes, it means any letter, and when it's used otherwise, outside of quotes, it means precedence. Now the greater than sign means directly dominates, and the dot means directly precedes. If you want to say dominates through a chain, we do this. We attach a star. So the star has basically the same meaning as inside regular expressions. And similar for precedence, it will be dot star. So precedes, but not necessarily directly. So for example, I'm gonna do a very simple and stupid query. Now we only have node names with no description of the nodes. That means we're gonna match any node. So this query will match any node that dominates some other node. And in practice, if we do it and tabulate the results, we get a table of the most common dependency pairs in the corpus. But if we do this in the sentence view, we get basically every sentence. And if you match, so the whole sentence consists only of such pairs. So that's okay. But typically we're not interested in any type of dominance. We want to look at only subjects, for example. Then we add the description, the label of the dominance edge to the greater than sign. So this will only find subjects, because in the Royal corpus, subjects are marked as sub and not SBJ. So this is something you need to know, and it's in the documentation. So now we find all the subject pairs. And again, we can run the query here, and we get a list of the most common verb, so predicate subject pairs in the corpus. So to know more about labels and so on, you could go to the funny webpage, help, and there's a link to the syntactic annotation scheme. So you can read that to understand how the labels are used. Okay. So with this, we can actually do quite complicated things. Let me just look at one possible research question you might have, which would be the word now, nunk. When this occurs inside reported speech, there's an ambiguity as to whether it means the now, so Caesar's now, or the speaker's now. So if you're into that, you might want to look at all instances of nunc inside complement clauses. This would look like that. So we're going to decode this. There's a node dominating another node with a comp relation, which is a complement clause, and then this top of the complement clause dominates a word nunc. And I obviously did a mistake. Oh, I guess I just added one quotes. We get three matching sentences here. So here we have nunc inside an ACI structure. So that is nice. And then I wanted to show you as the final thing. There are more examples on the slide, so you can have a look at them and you can think about it and think about queries you want to do. But in the readings I gave you, there's this paper on the use of tree banks in historical linguistics, and I make reference to a research by a dissertation by Alison Kirk on New Testament word order. And I just wanted to show you how you can replicate the data to find the data for her dissertation. It's a bit complex, so you have to put together a query step by step. That's really important. So, for example, if you want to look at to find only main clauses, we want something like an unbroken chain of pred relations from the top of the sentence down to the node we're looking at. So this will find any node dominating any other node by any amount of pred relations. The intention I had here is that the R node is the root. So I'm just going to say the R node should not be dominated by anything. Here we see the negation sign. We want this thing to be a verb. We're only looking at main clause verbs. Now we have only main clause verbs, which is what Alison Kirk is looking at in her dissertation. Then we want to have only where it's with subject or object. So here we have the verb dominates a subject with the relation sub, and dominates another argument with the relation either obj or obl. You see here again we have regular expressions. So an object argument or an oblique argument. So now we have only verbs, only root verbs with subjects or with subjects and objects present, like here. And then we want to say that these subjects should be nouns. So what we can do here is the S node should be part of speech. Well, actually, it says nouns or nominalizations, nominalized adjectives. So this subject should be an adjective or a noun, and the same goes for the object. So we redo the query. We find ever less material, but we're getting closer to what we're interested in. And then her final condition is that there should be no auxiliary verb, because she thinks that could disturb the word order. So we're going to add that. This says that it should not be the case that the V node dominates some other node, I call it aux, with the aux relation. And here I think this should it should be a verb. Now we run the query. You see by now it's an extremely complicated query, but we built it step by step, and you can look at the slides and more explanation of how this is done. Because it's so complicated, it also takes some time. But in practice, we're here actually getting in a few minutes all the data that went into a dissertation, right? So all the material. So although it takes some time to learn this, it is definitely worth it, and it gives you data very quickly. And on the final slide, you'll see later that there are some exercises involving how you can manipulate this very complex expression to get other results. So if you want to limit yourself to other kinds instead. So that was the end of my presentation here.
Okay, Doug, thank you very much. Really, it was very, very exciting and interesting. There are two questions in the chat. So one, well, is there any fee for registration for Ines? I don't think so. You can,
no,
of course, it's open. Yes, definitely. And there is a link in the class outline, so you can get the link there and you can use it. And then there is another question, Maria. So what differences you see between the different query interfaces, Ines, and the ones linked in the universal dependencies, PML and sets?
Right. So I should say that the plural corpus is also available as a universal dependency corpus. So we did convert our corpus to universal dependencies, and then it's available through the universal dependencies, their search tools. There's a little bit less of data in the universal dependencies format because our annotation scheme, our original annotation scheme, is more complex, has more detailed. So something gets lost. Some of the data gets lost in the translation to UD. But otherwise, you can also use that tool. Yeah. Okay,
thank you. And then, well, one last question is. It's interesting. I'm reading, so it's interesting which verbs could be annotated with a morphological value E, middle or passive. Do they have both voices?
Oh, right. Yes. So the middle or passive will, in general, then be. So we don't try to disambiguate if if it's a present tense verb, for example. So in Greek. It's mediopassive because there's no way it could be express the passive. Whereas in the aorist, obviously you can. There's an aorist passive. Yeah.
Okay. Thank you very much. I don't know if Giuseppe, yes.
Yeah, it was very. I think that Ines is especially useful because you can not only query but you can also see the tree because so you get the visualization of the tree, and that's extremely useful when you are looking for something. And as for the question about the XML, I think that we can I can talk about this next week.
Yes.
This is useful for students.
Yes, thank you, Giuseppe. Yes, because we have a big audience now. We have 20 people following this common session through YouTube, and I think that this is a good model because people can watch the video, and then in the meantime they can ask questions in the chat, and of course if they want they can also join the Hangout. But I think that this is a perfect model. So you have 20 people for this common session. I think it's great. So thank you very much. It was a great common session to start Sunoikisis. We have your class outline with readings, links, etc.
And the slides as well, right?
Yes, of course. The slides are in the class outline. In the class outline, you have the slides, both the slides and also the broadcast. So you will see, you have the link, and so you can see anytime you want this common session. So thank you, really, thank you very much, and so see you next week with Giuseppe for the second part of the introduction to Treebanking. So Doug, thank you very much for joining us.
Thank you.
Okay, see you next week.
See you next week.
See you. Bye.